Hello and welcome back, everyone. Today we want to see some examples of how we can automate development and quality, how we can make our life easier, especially as our product progresses. Um, and in particular, we will touch upon several topics. One of them is DevOps, which is a huge topic, but we will look at some of the definitions and also some of the common practices within DevOps. Then we will have a slightly deeper look into unit testing as one of the practices within development, within software quality, and within DevOps as well. And then we will look at test-driven development, which is a development philosophy that works well with the idea of automation. Okay, so let's get started. First and foremost, what is DevOps? If you are familiar with the topic, you know that there is no one specific definition, since a lot of it's actually a set of practices and philosophies that together are called DevOps. But the historic context for it is that um, is this idea that developers and IT operation teams should work together. And ideally, these skills should be combined within the same team. So this is kind of a culture where this divide between engineers, between software engineers, between developers actually, and IT operations people uh, should be breached, you know. And development is clear. IT operations, or is actually their duties include a lot of things, such as networking, environment, deployment, security, a lot of things, administration. So the idea of DevOps is, can we introduce tools and practices such that these things will come together seamlessly, such the activities in software development and IT operations will come together seamlessly. And the goal of DevOps, the main goal, is to enable engineering teams to deliver software, reliable, high quality software faster. So the whole idea here is that we want to accelerate the development to deliver the value faster, to get feedback, and to increase the quality. And in practice, what it means. So we gave some kind of, I would say, not vague, but generic definitions, uh, which if you don't know the topic will be kind of vague for you. Then we establish the goal. Once you understand what is it that we want to achieve, I think it becomes easier. And what does it mean in practice? Mostly DevOps in practice, it means that these are methods and tools and philosophies on how to build, test, release, and monitor software applications. Okay, so you want to build them in some better way, right? Using the best practices. You want to test them using the best practices, release, in other words, ship to the customer, right? Deploy and monitor their performance in production and in test environments. Okay, so there are some common practices, practice areas within DevOps that are often targeted. And of course, this is not a static list. It will expand. Some things will become more relevant. Some things will be less relevant as our technology progresses. But now, right now, an important area is the part of code review. So in the previous week, we discussed how code review is critical for maintainability and for software quality and for the team to be on the same page. So DevOps has this goal. One of the goals of DevOps is to automate code review, make it more efficient, more effective. And part of it is automation, is continuous integration. Probably you've heard this term, CI/CD, continuous integration, continuous deployment. So automating code review, a big part of it happens through continuous integration. And part of this continuous integration is that we automate some testing and we conduct static analysis. So we check the code statically. We try to um, run to analyze the code. Then another part of it is creating these environments, separate environments, testing environments where these newly implemented changes can be tried and touched and tested. Okay, this is another important part. And of course, it's another important part about automating code review is facilitating communication between the author of a pull request and the reviewers. So it can include alerts, notifications, and so on and so forth. Um, uh, Together, the goal together, these practices come together to um, help us conduct code review in a more coherent and efficient manner. Now, another important area of practice for DevOps is deployment. So how can we automate deployment? And this can include such as deploying to production or to a subset of users for beta or alpha testing. Then also another thing that we want to be able to deploy without downtime. So we want the service to be available throughout. And then sometimes we also might want to be able to roll back to prior versions. These are some of the examples of deployment automation, of deployment of automation of deployment. And what's important here is that at this point you want to check that what changes that you have implemented are of decent quality. And here you want to ship and deliver these changes to your users or to a subset of them. And then, of course, the other area or the third area is application performance management. So you want to try to understand how is your application doing. And here you can see we have the thermometer, right? This is kind of, you want to understand what is the health status of your system. Is it healthy? Is something wrong? And normally it is implemented through introducing some metrics that are relevant for you, logging what is happening in the system, and then monitoring it, using these metrics and logging to monitor and to try to check that uh, all important processes are running as they should. And if something goes wrong, we need to alert the developer. So you can see it's quite a wide set of practices. Um, Now, of course, not every development team does everything on this list. Some teams do more, some teams do less, but it is clear that DevOps becomes more important as your product grows, as you have a stable audience of users who will not tolerate low quality, as you start running critical tasks such that it cannot you cannot afford to have bugs or to have downtime. So as your product matures, DevOps will become more and more important, and you will try to integrate as many of these practices as possible. However, when the product is at its early stage, you will integrate some of them, the ones that make most sense to you, and the ones that give you easy wins for relatively small effort. And of course, nowadays there are a lot of tools. So let's look at one practice that can make our life easier even at this stage. And this is testing, and in particular, unit testing. So what is unit testing? To understand unit testing, we can look at the hierarchy, the testing hierarchy. That unit testing is the most basic, the most, from the point of view of scale, it's the testing that concerns itself with single units, with units within your, like smallest units within your program. Then there is integration testing that checks whether separate units can work between each other. Then there is system testing, where the system can work as a whole. And then there is acceptance testing, where we check whether the system does what the customer or the user wants it to do. So, for example, we defined acceptance criteria. Most of the time, acceptance criteria is at the level of acceptance testing, since it looks at the system from the user point of view. Uh, and other types of testing are kind of on a lower abstraction, and they are more engineering centered. So let's maybe it will be easier if we look at a coffee machine. So um, coffee machine has separate modules, right? It has thermometer, or maybe this is pressure. Then it also has some water bank inside, water container. It has the beans container, and maybe it um, uh, actually grinds the beans. So you see there are different modules and different functions. Unit testing will test each module and each function separately. So it will check whether the thermometer or barometer, whatever it is, whether it works. And it will test it in isolation from everything else. Um, and it will also check that whether the coffee is served. Once everything is there in place, whether the coffee can be poured into the cup. And integration testing in this case will see whether the coffee can be served, can be poured, and how it will affect the barometer and thermometer. Okay, so it will see how these two work together, whether they are working out as they should. And the system testing will test the system as a whole, and acceptance testing is when a user comes and tries our coffee or tries to make coffee using the coffee machine. I hope this is clear. And um, to reiterate, right, some of the core ideas. Individual components of a software are tested. So components could be modules, individual modules, it could be individual functions. And the purpose is to validate that each part, each unit is working as it should. And a unit in this case is the smallest testable part of any software. Um, it has one or few inputs and usually a single output. Sounds like a function, right? Or a module that does one clear um, action. And an important part here is isolation. Since we are not doing integration testing, we are not trying to see whether the modules can interoperate between each other. We are looking at each model in isolation. So in other words, when we're doing unit testing, we're trying to verify whether this particular unit is working correctly or not. And this isolation is quite important. In practice, it means that if your module depends on other things, you should supply stubs. You should supply imitation of these dependencies such that we are not testing the functionality of those dependencies. For example, if you're testing a backend function, if you're testing whether a function at your backend is working, uh, you might want to um, do it without relying on the network. Since if the problem is the network, for example, if your test fails, it might fail to the problem with the network or problem in your business logic. So in this case, you want to isolate all other factors that might lead to failure and to make sure that it only fails if your logic there is an error in the logic. Okay. And let's have a look at a simple example. Again, we're going back to the coffee machine. And when we initialize the coffee machine, there are no beans. And we can add beans, okay? And we can get the current amount of the beans. And if we wanted to test such function, we would write a simple test that, okay, we want to see whether we can add coffee beans or not. We would initialize coffee machine, we would try to add 100 beans, and then we would like to assert or make sure that the current amount of beans is equal to 100. You can see very simple idea that you have a function and you check whether it behaves correctly when you give it a particular input and you expect a particular output. This is one testing philosophy. There are also other testing philosophies, but when it comes to dynamic testing, which includes unit testing, you give inputs and you expect certain outputs. Okay. Um, and if it's not working, then something is wrong. It's an indication that something is wrong. Okay. Um, Another idea that builds on top of unit testing is test-driven development. And the idea of test-driven development that everything is driven by tests, right, as it says. What it means that you write tests, you think about test cases before writing the actual software. So we just said that a test case, a dynamic test case is when you give certain input and you expect certain output. In test-driven development, you will try to think, okay, what are the inputs I want to give to my program and what I would expect the outputs to be. So you try to think about it and formulate some inputs and outputs even before um, even before writing the program itself. And you can also try to think, okay, what do I want to make sure happens while my program is executing this or that command? And the procedure is the following. You write a test, you write the code to make the test pass. So first, when you write a test, you can run it, it should fail, right? Because there is nothing. Then you try to write the code that will make the test pass. Then you go, when it passes, it means, okay, that your functionality is correct. You will try to refactor the code to improve the quality of either the maintainability or performance or whatever. But first, your goal is to make it working, then to refactor it. And at each stage, you can always rerun the test to make sure that, for example, your refactoring didn't break anything. And also, you can expand. Let's um, um, we will see an example, but before that, right? The core idea of test-driven development is to make you think what is the expected behavior of your program before you start coding it. So one approach is when you code and you think on the go of what should be the behavior. Test-driven development and a bunch of other approaches are stipulating that you should think how it needs to behave concretely before even writing the software. And this is a more sound approach. It kind of is, yeah, it kind of is. And there are some principles that fail first. Uh, since you write the test before writing software, it should fail. If it doesn't fail, then something is wrong with your test case. Even if it passes without you writing any software, it means that um, your test case is useless. Another thing that you should also make sure that when you write a wrong program, a program that you know for sure that it is wrong, the test case should also fail. And if it doesn't fail when you wrote a wrong program, when you purposefully wrote a wrong problem, it means your test cases are not good enough to detect a problem. Okay, then there is the idea of incremental development. You write a test, you write code that passes this test. You can add other tests. For example, you can try to think, okay, what other scenarios I need to cover? Then you try to cover them. So it's an iterative incremental process that you write tests, write code, add some more tests, and the code fails again, then you try to meet the requirement. And refactoring, of course. That first you try to make it work and then you try to make it pretty and efficient. And the beauty of testing of test-driven development that you can run the tests again and again. In other words, to make sure that you haven't broken anything. This idea of not breaking something that has been working before is called regression testing. So you are trying to make sure that you are not regressing. Regress is the opposite of progress. So when we build software, we try to progress. Regression testing is when we try to make sure that we're making a progress and we're not going backwards. Okay, so the cycle. You write a test, it fails. You write some code until it passes, then you refactor, and then you go into cycles. Let's see an example, right? So um, we will continue with the coffee machine, right? So now we first will write a failing test. We want to we will want to do some setup, so we initialize the coffee machine. And then we will, for example, one thing that we can check whether it can do it or not is whether the machine can make latte for us. Okay. And here is the beauty of tests that you think about the specification and what will be the inputs. You assume that latte requires 10 beans, 100 grams of water, and then it's the number of um, the coffee type is 2 for latte. And then you assert that the coffee that you've made is latte indeed, that there are no more beans. In other words, the beans were spent. And if they weren't spent, it means your latte doesn't have any beans. And then you want to make sure that the water has also been spent. So this is the state of your machine that you expect to have at the end. You can also have checks for the machine before you initiate the procedure. This is also fine. But the main thing is that you think about the inputs and you think what to expect. From this test, I can also understand how your code is supposed to work. So it is not only it fulfills not only the function of um, verifying the quality, but also the function of documenting the code. So that's another benefit of it. And this setup function is important because every time we run a test, we want to start from a blank list. We don't want to have consequences of the previous test. So this setup function will initialize a new coffee machine for each test. And this is again the idea of isolation. It's isolated from other modules, for example, unit testing, but also each test case should be isolated from other test cases so that if one fails, its failure or success doesn't affect other test cases. Okay. Uh, yeah. Now we will run the test. So we wrote the test, right? And we can run it. Good. Uh, it obviously should fail. Okay. Then we will write the minimal code to pass the test, right? So we already have the initialization of machine. We'll add the fact that there is also water levels, that we don't only have beans, but we have water. We can add beans. We can add water or dispense water, right? So we can add some amount. And then we can make a function called make coffee. So we will it will make sure that the beans, if it's any coffee, we have to make sure that at least there are 10 beans. Then we also want to make sure that there is at least 100 grams of water or milligrams, right? And then we can check which type of coffee it is. So for now, we can do espresso and latte. That's it. And if anything else comes, we say that it's an invalid coffee type. So we can only make two. Um, and we can run the test. Will it pass? Will our test pass? Um, in fact, it will fail, but it will fail at the very end because we don't have functions such as get beans and get water level. And the test itself, if you remember, that it includes the get water level functions and so on and so forth. You see, so here your test will not, your program will not pass the test until you supply all the important parts of the implementation. That's one way to write a test. And if you think about it, this is not just a unit test. This is quite an advanced test that checks, you can say it's a system testing. It checks the system as a whole, or at least integration, because it checks how several functions come together and such. Okay, so at this level, we are already writing a test for higher level. But if we wanted, we can also write, before writing a huge test like this, we can also check that we can add beans, that we can add water, and that we can request different coffee types and so on and so forth. Okay. Um, one more thing, we can serve it wrong inputs and check that our system can handle wrong inputs as well, such that it's robust. it doesn't, it's not only good at handling good input, valid input. Okay, and we will run the test again, and it should pass. In this case, if we implemented everything, the test should pass. And then comes the time to refactor our code. And if necessary, sometimes you already see that it's good enough and you keep it as it is. But most of the time, especially when you're writing something complex, you will need to refactor. And the nice thing about it here is that uh, you at first you're wearing like a junior's hat that okay, just make it work. And then you will try to enable another skill of yours where you will try to write code that is also uh, maintainable, and you will also can concentrate on performance such that you are not using more resources than you should. Okay, and you can expand. You can add other tests to the same functionality. You can add tests for the new functionality. Okay, and to kind of wrap up, why is it useful? Automation is a huge thing that you write the test once, you can run it again and again. Of course, this automation, whenever your specification changes, your tests that cover that part of the program will become obsolete. So automation normally, the automation of testing happens later on when there are some more or less mature or stable parts of the product. Otherwise, you will have to write tests again and again. Um, it might be fine for some of you, not so fine for others, but this is an important point. Okay. However, if you have a stable part of the program and you wrote tests for it, this is huge, that you can run them anytime. And this ability to run them anytime is what allows you to run them frequently or often, to catch regressions. In other words, to catch newly introduced bugs, bugs which weren't there before, but you introduce them when making changes to the program. Mhm. And then documentation. As we already said, tests are nice way to demonstrate what kind of inputs and outputs do you expect. And it's a design aid. So the argument here is that by writing tests, you will think more and deeper, and this methodology will make you a better coder. That's kind of the idea behind it. And if we go back to DevOps, we said that the first area is automating code review, that there is continuous integration, and within continuous integration there is automated testing at which we looked, and there is also static analysis, which we haven't touched in this lecture, but it is something that you will look at as part of your assignment and as part of your lab today. Then, um, obviously, there can be different environments to test the newly implemented changes. And our overall goal is to what? Is to help the developers to communicate between each other, especially the author and the reviewers of the code of the pull request. Then there is deployment automation or automating deployment or continuous deployment, right? CI/CD. Um, and we should be able to deploy the changes that we have implemented straight away. We should be able to deploy to all users or to a set of users or only to testers. Ideally, when we deploy in production, there should be no downtime, and we should be able to roll back to previous versions in case we introduce some bugs, and this happens. And performance management is a whole different level. It's when you monitor your system that is working correctly, and this is an important part. And of course, if you have automated tests, you can, this is part of monitoring. You can run the tests anytime to check, okay, my program is working as expected, you know. Metrics are important. We will also look at some product metrics, popular product metrics, and how to find the metrics that are suitable for your product. But this we will look at in the future lectures. And these metrics and logging can be looked at from the engineering point of view, where we're looking at the stats and logs of the system that are important for engineers, that the system is not down, that there are no bugs occurring out of nowhere, that the security is okay. But there are also metrics which are important for business people, or such as what is the conversion, what is the engagement rate, and such and such. Okay, and of course here an important thing is that it should be able to alert us when something is wrong, when the system is unhealthy. It should notify us such that we can fix it. Okay, and this is uh, as areas of DevOps, there are a lot of things to cover. Uh, Look at what is relevant to you right now, and uh, how you will understand that it's relevant for you when it's becoming too difficult. When you see that, okay, every time you build something, something else breaks, or the code review is not working out for you. Why? Maybe you can make it more efficient, or the deployment takes too long, or it's hard to test your newly implemented changes. Then you will try to look into these practices, which were born out of need. So engineers faced some difficulties, and by facing these difficulties, they figured out ways to kind of mitigate them, like, or to make them less obstructive. And uh, performance, this is very important because you should be able to see that your system is working as it is intended. And it's also important for you to run experiments, but this is a different topic, and we will touch on aspect of it. Okay. Um, One practical exercise that you will have is establishing the GitLab CI/CD pipeline. So GitLab has very nice built-in tools that can also interoperate with third-party tools. So you will get to practice establishing a CI/CD pipeline in GitLab. Um, Lucky for you. Okay. Thank you, guys. Take care.